You don't hate me, do you? Did you try it? I know it's a lot of symbol gymnastics and your eyes start to spin, but hey, take advantage of this video and check your work, or if you got stuck, see if I can get you unstuck. But just one time in your life, slug through the trigonometry / algebra symbol manipulation of this Jacobian to see where the rho squared sine phi Jacobian comes from in the context of spherical coordinates. So I tried to save some time on the video. Here's the conversions that are really relevant in this case. Here's that 3 by 3 determinant with all the different partial derivatives that are needed. And I just did them. I thought that part, you could pause right now. Pause the video right now. And check to see if you got the same partial derivatives that I did. I think I got them right. All right, but I'm going to now jump down and start working on them. I guess I can just do it right here. Let me put me up here to get my mug out of the way. All right, here we go. Just like the cross product where we had I, J, K, we take out the column and the row, we're left with the 2 by 2 determinant, all that stuff. It's the same computational procedure. So we're going to start with that sine phi cosine theta. That was this piece. Take out the column, take out the row. What we're left with is this 2 by 2 determinant. Now it's not that bad because look, this cross product, 0. Nice. So we're going to have 0 minus this product. And this product is, let's see, it's going to be a minus rho sine phi and then times a rho sine phi cosine theta. Are you smiling yet? Do you see it? Rho squared sine phi is the sine phi. I wonder what's going on there. Let's see. Then it's minus. Remember, it's plus this one, minus this one, plus this one. So minus, let's take this next column. So it's a rho cosine phi cosine theta. And it's going to get multiplied by. Let's take out the row and the column. So it's this times 0. All right. Minus this product. So 0 minus this product. Cosine phi rho sine phi cosine theta. And then I'm just going to have to go down to this next line. It was plus. We do the same thing here. Now plus a negative, so it's going to be a negative rho sine phi sine theta times, now take out its row and its column. We're left with this 2 by 2 determinant. So we need this product. All right, so negative rho sine phi sine theta minus this product. Boy. All right, you guys, I'm sorry. Here, I'll pause it and fix it, okay? All right, I tried to clean it up here a little bit. Double check your work. What I'm going to do is clean it up by getting rid of some of these zeros and distributing a bit. So let's see. What we've got now is this. So sine phi cosine theta minus minus plus. All right, so we've got rho squared. Let's see. We've got sine phi cubed. We've got cosine theta squared. Double check that. Do you see as we multiply this, distribute this through 0 plus sine phi cubed cosine theta squared. I think I got it. Next one. 0 minus minus plus. Let's see, rho squared. Let's see, cosine phi squared. Cosine theta squared. Cosine phi. All right, double check that. Double negative positive, rho squared. Cosine phi squared, cosine theta squared, sine. Cosine phi squared cosine sine phi. Huh. You're watching that right now going, duh. All right. Then over here, let's see, plus minus 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 plus. So let's see, we're going to have plus rho squared sine phi cubed sine theta squared. Double check that. Rho squared sine phi cubed sine squared theta. Yep. Minus minus plus. Let's see. Rho squared sine phi sine squared theta cosine squared phi. Wow, look at that. 1, 2, 3, 4 terms, and somehow all of this is going to boil down to rho squared sine phi. Now what happens next is just a whole bunch of algebra and trigonometry. What I'd like you to see first is, suppose we kind of clump together the first two and the last two terms, just to get started here. And what I see in these first two terms is a common factor of cosine squared theta. So I'm going to factor out a cosine squared theta. What I'd be left with is rho squared sine cubed phi plus rho squared factored out, factored cosine squared theta, cosine squared phi sine phi. And then over here, I see a common factor of sine squared theta. Let's factor it out. So if we factor out a sine squared of theta, we'd be left with rho squared. We'd still have a sine cubed phi, factored out the sine squared, plus rho squared sine phi, factored that out, cosine squared phi. Rho squared sine cubed phi. Rho squared sine cubed phi. Oh. Rho squared cosine squared sine. Rho squared cosine squared. Oh my gosh. This and this are now a common factor that can be factored out. So watch this. If we factor out rho squared sine cubed phi plus rho squared cosine squared phi sine phi, factor all of that out. What's left on this first piece here is cosine squared theta plus, remember rho squared sine cubed phi, boom. Rho squared cosine squared sine, boom. Factored it out. What's left? Sine squared theta, which is 1. So we now have this thing times 1, which is just that thing. All right, now, if you think you got it, take it from there and see how you can finish it off, and then come back and see if you're right. But I'm going to continue, because now what I see is a common factor of rho squared. So I'm going to factor out a rho squared. What else do we have in common? We have a common factor of just 1 sine of phi. So we'll factor out the sine of phi. So if I factor out rho squared and just one of the factors of sine of phi, that would leave me a sine squared. And if I factor out those, I'm left with a plus cosine squared of phi. Again, that's 1. And we're left with just rho squared sine phi. Ta-da! So yeah, by the Jacobian, we can now make a claim that when you convert from rectangular coordinates to spherical coordinates, that dv, dx, dy, dz, back over here in rectangular coordinates, has to become rho squared sine phi d rho, d theta, dv, d phi. And I'm going to go take a nap.